Hello students, in this lesson we'll talk about how to compute the t-value for a two-sample t-test with matched samples or matched pairs. So we also call these population as the two related populations. So let me quickly show you one question, then I'll come back to this formula. So we'll have something like this. Here in table 11.3 we have 10 employees and scores are taken before training, that is this column 25, 26, 28 and so on, and scores are taken after training, that is 32, 30, 32 and so on. We have to check whether there has been increase in the scores after training or there has been some change after training. So please pause the video, read this question very carefully. So I'll come back to this and let me just quickly show you the formula for this. One more thing here you can see is we are calculating D. D is this thing minus this thing, 25 minus 32, 26 minus 30, 28 minus 32 and so on. We will calculate D value for each of these cases. This is one case, this is second case, and we have 10 cases. So let me show you the formula here. So the t value will be calculated as follows. We have to calculate d bar, the mean value of all the d values. We have 10 d values. We have to calculate the mean value. In this formula, we have d bar. Mu d is 0, that is population mean. SD is the standard deviation of d, that is calculated using this formula or any of these. These are the shortcut formulas. This is the main formula. And we have to calculate the degree of freedom n minus 1. So t value we can calculate by plugging in the d bar, SD and n. Degree of freedom by n minus 1. So let's quickly have a look at that question. So your question you should have read by now. Let me go to the calculations part. So here we have calculated d bar. D bar is the sum of all d values divided by the number of sample size. So 5 minus 58 divided by 10, that is minus 5.8. Here we have calculated the standard deviation of d, that is 4.4422, and we plug in all the values to calculate the t value. The t value is minus 4.13. So now after the calculation of t value, we have to compare this with the critical t value. So for critical t value, we need some information, that is degree of freedom and the level of significance as well as the tail of the test. Here we look for the two-tailed test. Okay, so for looking at the t value and finding out, let's go to the t table. So here we have a t table and we will find out the critical t value in our case. So we have a degree of freedom which is 9, 10 minus 1 is 9. So we'll look only for this, only in this row. Now we look for the significance level. So our significance level for two-tailed test, as we were doing two-tailed test, is 0.10. So this is the column and this is the row. So number is 1.833. So our critical value will be 1.833. Now we will compare this value with our critical value. We'll only compare the absolute numbers. So our value is greater than the absolute value, 4.13 is greater than 1.8. So we'll say we can reject the null hypothesis that is not equal to 0. The change is not equal to 0, and we can go with the alternate hypothesis, that is the change is not equal to 0. There has been some change. H0 says there is no change. So that's how we interpret this result. So that's all for the two sample t-test. It was a quick video. Hopefully I'll make a elaborated long video on this test.